So in this question, we're making a subclass of the question class, and it's kind of like the choice question that you've seen in the book and in the video, but it's a little different. You're familiar with these questions because I've been asking a bunch of them in the quizzes, because they're more flexible than just a plain multiple choice question. So there's any number of correct answers, and so the difficulty with these is that there is some pattern of correct answers, and then the student has a different pattern, and you really need to grade them on the difference. You can't just give the student a pass on some of them, because otherwise the student would just say yes, 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 and they'd get a full score. So the way this works is that if the correct answer is, in this case, that the first option is true, the fourth option is true, and the others aren't, then for each of the four options, you look at what is the correct answer versus what is the student's answer. And if they're different, then there's, of course, no score. If they're the same, so if the correct answer is this one didn't apply, and the student also said this one didn't apply, then you give a fraction of a point. Well, how much? It's in this case, it's 1/4 of the full score. If there were 6 choices, then would be 1/6 of the full score. I'm not actually testing this, but so you would in general take 1 over n. So again, here, the correct answer and the student's answer are in agreement, and you give another 1/4 of that. So that's the algorithmics of it. And so when we look at the code of that, that's pretty straightforward. So here, for each of the possible answers, so I guess I should also explain the way the input format was, which is a little bit ad hoc, but so the way that I've said it is that I'm assuming that somehow the student, because we don't really have an input format with checkboxes and stuff, will just enter a sequence of numbers. So if the student thought that 1 and 4 were the correct answers, they would provide this string. When we build up the question, and I'll show you how that works a little later, we might be getting a string such as 2, 4 as the proposed answer. So now how do we compute the score from that? That's the algorithmic part. So I've done that here. So we want to count the number of places where the student's answer and the correct answer agree. So the student answer is what I call the response, and the correct answer I call the answer. And so if we have 4 answers, then we're going to be looking at 1, 2, 3, and 4. And now we want to know, do they both, like for example, look at the 1. You ask yourself, does the answer contain the 1? And then you also want to know, does the response contains the 1? And that 4 possible choices, but the 2 that are of interest for us are that both do or that both don't. In this case, the answer and the response agree, and then we would give another point, or really a fraction of a point, because they all have to add up to 1 in the end. So you find that over here. So I'm counting what I call the number of matches. And if the response and the answer contain, in this case, the 1 or whatever it was, then we increment the matches. And if neither of them contain, then we also increment the matches. But in the other 2 possibilities, we don't. So in the end, we return the matches, which in the example that I had before was, in the problem statement was 2. And we divide by the size of the choices in a multiple choice question with 4 answers, that would be 4. So let's say we had 2 matches out of 4, that would give us a 0.5. If all of them match, that means the student and the answer were in total agreement, then we would get a match of 1. That's the reason I made matches into a double, so that I wouldn't be losing anything here by this division. So that's the algorithmic part. And that's really a very important part. But when you deal with object-oriented programming, you also have to get the object straight. So let's see what we've done for this. So the multiple response question has to extend the question class. That's simply so that when you have a bunch of questions, that some of them could be plain old questions, some of them could be multiple choice questions. Now there is a little bit of a difficulty here with how you set things up. So we have a get score method that we override. And notice here that we completely override it. We couldn't care less what the basic question class deals with answers, because it had no way of dealing intelligently with this situation. So we kind of have to build up a parallel answer string that has nothing to do with what was in the question, and that's built up in the add choice method. So every time that this Boolean correct here was true, then we remember the number of that. So remember, choices.size, when we added the first answer was 1, when we added the second answer was 2, and so on. So that gives us the code of the correct answer. And so if the correct answers were, say, 1 and 4, then eventually here we would be building up the string, first starting with the string 1, and then eventually we would be adding the 4, and that would be in this answer variable. So when you look at the state, you see that the question text is stored in the question. We don't even override the setQuestion method. But the choices we do collect, just like in the example in the textbook and in the videos, and we use that here for the display. The display method is a straight copy of what you found in the videos and in the book. And then when it comes to to adding the choices, we do this a little differently. In the choice question class that you've seen in the video, we would pass on a choice to the superclass. Here we don't do that at all. The superclass is not capable enough for doing that. So we do everything ourselves in here. So in general, you will see that when you try to fit something into an inheritance hierarchy, you do have to really think about quite hard about what is the state that you want to collect in the subclass versus the state that you have in the superclass. And that is connected, but it is somewhat different from, what is just the basic algorithmic question that you need to do to solve your problem.